Good day everyone! In this video, we will discuss about the ellipse with center at h, k. We have defined the ellipse as a set of points on the coordinate plane such that the sums of the distances of the points from the two fixed points are constant. The fixed points are called the foci of the ellipse, denoted by f(1) and f(2). Also, we have discussed that the general form of the equation of an ellipse is a second-degree polynomial in two variables, that is, ax squared plus cy squared plus dx plus ey plus f equals 0, where a, c, d, e, and f are elements of real numbers. While the standard form of the equation with center at h, k is given by x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1 for horizontal ellipse, and y minus k quantity squared over a squared plus x minus h quantity squared over b squared equals 1 for the vertical ellipse. Moreover, we have also determined the elements of the ellipse as the following. Center is the middlemost point of an ellipse. Vertices of an ellipse are the endpoints of the major axis. Each vertex is a units away from the center. Covertices of an ellipse are the endpoints of the minor axis. Each covertex is b units away from the center. Foci are the fixed points of the ellipse. Each foci is c units away from the center. Major axis is the line segment joining the vertices of the ellipse. The length of the major axis is equal to 2a. Minor axis is the line segment joining the covertices of the ellipse. The length of the minor axis is equal to 2b. Latera recta, or the plural for latus rectum, are the line segments that contain 2 points on the ellipse and passes through the foci f(1) and f(2). And finally, directrices are the lines outside the ellipse. The equations of the directrices are x equals h plus and minus a squared over c, or y equals k plus minus a squared over c. Let us have an example. Rewrite the equation from general form to standard form and describe the ellipse. The first thing that we need to do is to write the equation in standard form. To do that, we need to isolate first the constant to the right term of the equation and group the terms according to its variables. Thus, we will have 9x squared plus 18x plus 25y squared plus 100y equals 116. Let us group the terms with y as your variable and x as your variable. Next, we need to factor out the numerical coefficients of the squared terms. So here, we need to factor out 9, and here, we need to factor out 25. Therefore, we will have 9 quantity x squared plus 2x plus 25 quantity y squared plus 4y equals 116. Then, let us do completing the square on these two binomials here. Therefore, we will have 9 quantity x squared plus 2x plus 1 and 25 quantity y squared plus 4y plus 4. Recall that in doing completing the square, we need to divide this number by 2 and square the answer. So 2 divided by 2 is equal to 1. Times 1 is 1. Here, we need to multiply 4 by 2. So 4 divided by 2 equals 2. Times 2 itself, 2 times 2 equals 4. Continuing this equation, we will have equals 116 plus, remember that what you have added on the left side should be also added on the right side. However, since we have 9 here and 25 here, we need to multiply 9 to the constant 1 and 25 to the constant 4. So 9 times 1 is 9 plus 25 times 4 is 100. Moreover, factor the perfect square trinomials and simplify the right side of the equation. So the factors of x squared plus 2x plus 1 are x plus 1 times another x plus 1 plus 25. The factors of y squared plus 4y plus 4 are y plus 2 times another y plus 2. And 116 plus 9 plus 100 is equal to 225. Express these factors as a square of a binomial. Hence, we will have 9 quantity x plus 1 squared plus 25 quantity y plus 2 squared equals 225. Finally, divide the whole equation by the constant number. So we need to divide everything by 225. Make sure to lowest term the numerical coefficient here and the denominator. So 9 over 225 is 1 over 25. Therefore, we will have x plus 1 quantity squared over 25. Plus, on the other hand, 25 over 225 is 1 over 9. So therefore, that will be y plus 2 quantity squared over 9 equals 225 divided by 225 is equal to 1. Therefore, we already have this equation as our standard form. From the standard form of the equation that we have solved earlier, which is x plus 1 quantity squared over 25 plus y plus 2 quantity squared over 9 equals 1, the higher denominator will be a squared and the lower one will be b squared. Hence, we will have a squared equals 25 and b squared equals 9. Since a squared is the denominator of x squared, then the orientation of our ellipse is horizontal. Additionally, the center of the ellipse is at h, k, wherein this is your h and this is your k. Therefore, the center of our ellipse is at point -1, -2. Furthermore, since a squared is equal to 25, then it follows that a is equal to 5, which is the distance of the vertices from the center. On the other hand, since b squared is equal to 9, then it follows that b is equal to 3, which is the distance of the co-vertices from the center. For the foci, we need to solve for the value of c using the formula c equals the square root of a squared minus b squared. Using the values of a squared and b squared, which are 25 and 9 respectively, we will have c equals square root of 25 minus 9, which is equal to the square root of 16, which is 4. Therefore, the distance of the foci from the center is 4 units. Since we already have the center, the orientation, the value of A, B, and C, we can now determine the other elements of the ellipse by graphing. From our previous solution, we have learned that the standard form of the equation is x plus 1 quantity squared over 25 plus y plus 2 quantity squared over 9 equals 1. The center is at negative 1, negative 2, and the orientation of the ellipse is horizontal. Since the ellipse is horizontal, then it follows that the vertices are on the right and on the left of the center, with a distance of 5 units since A is equal to 5. With that, we can see that the vertices of the ellipse are the points negative 6, negative 2, and 4, negative 2. On the other hand, the covertices of the ellipse are above and below the center, that are 3 units away from it, since B is equal to 3. Observe that these points are negative 1, 1, and negative 1, negative 5. With the vertices and covertices, we can now draw the ellipse this way. The foci are collinear with the vertices. Therefore, they are also on the right and on the left of the center, and they are 4 units away from it, since C is equal to 4. Thus, the foci are the points negative 5, negative 2, and 3, negative 2. The length of the latera recta is represented by 2b squared over A. Substituting the values of b squared and A, we will have 2 quantity 9 all over 5, which is 18 over 5 units. Finally, since the ellipse is horizontally oriented, then the directrices are the vertical lines with the equation x equals h plus minus a squared over c. Substituting the h, a squared, and c, we can see that the directrices are the lines x equals negative 7.25 and x equals 5.25. Let us have another example. Rewrite the equation from general form to standard form and describe the ellipse. We have the equation 25x squared plus 16y squared minus 100x minus 32y minus 284 equals 0. Again, the first thing that we need to do is to write the equation in standard form. To do that, we need to isolate the constant term to the right side of the equation and group the terms according to its variables. Therefore, we will have 25x squared minus 100x plus 16y squared minus 32y equals 284. Next, factor out the numerical coefficients of x squared and y squared. So we will have 25 quantity x squared minus 4x plus 16 quantity y squared minus 2y equals 284. Then, let us do completing the square on these two binomials. So, 4 divided by 2 is 2, squared is 4. So, we will have 25x squared minus 4x plus 4 plus 16 quantity 2 divided by 2 is 1. Squared equals 1. So, we will have y squared minus 2y plus 1 equals 284. Again, we need to remember to add the same values on the right side of the equation. So, we have 25 times 4 is 100 and 16 times 1 is 16. Moreover, factor the perfect square trinomials and simplify the right side of the equation. So, we will have 25 quantity x minus 2 times another x minus 2 plus 16 quantity y minus 1 times another y minus 1 equals 284 plus 100 plus 16 is equal to 400. Express these factors as a square of a binomial. Hence, we will have 25 quantity x minus 2 squared plus 16 quantity y minus 1 squared equals 400. Finally, divide the whole equation by the constant number 400. So divide this by 400, also this term, and finally this term. Make sure to lowest term 25 over 400, 16 over 400, and 400 over 400. So therefore, we will have 25 over 400 is equal to 1 over 16. So we will have x minus 2 quantity squared over 16 plus 16 divided by 400 is 1 over 25. So we will have y minus 1 squared all over 25 equals 400 divided by 400 is 1. Therefore, this is our equation in standard form. From the standard form of the equation that we have solved earlier to be x minus 2 quantity squared all over 16 plus y minus 1 quantity squared all over 25 equals 1, the higher denominator will be a squared and the lower one will be b squared. Therefore, a squared is equal to 25 while b squared is equal to 16. Since a squared is the denominator of y squared, then we can say that the ellipse is vertically oriented. Additionally, the center of the ellipse is at h, k, wherein h is equal to 2 and k is equal to 1. Therefore, the vertex is at 2, 1. Furthermore, since a squared is equal to 25, then it follows that a is equal to 5, which is the distance of the vertices from the center. Also, since b squared is equal to 16, then b is equal to 4, which is the distance of the co-vertices from the center. For the foci, we need to solve for the value of c using the formula c equals square root of a squared minus b squared. Using the values of a squared and b squared to be 25 and 16 respectively, then c is equal to the square root of 25 minus 16. So we will have square root of 9, which is 3. Therefore, the foci are 3 units away from the center. Since we already have the center, orientation, values of A, B, and C, we can now determine the other elements of the ellipse by graphing. From our previous solution, we have learned that the standard form of the equation is x minus 2 quantity squared all over 16 plus y minus 1 quantity squared all over 25 equals 1. The center is at 2, 1. And the orientation of the ellipse is vertical. Since the ellipse is vertical, then it follows that the vertices are above and below the center with a distance of 5 units since A is equal to 5. With that, we can see that the vertices of the ellipse are the points 2, 6 and 2, negative 4. On the other hand, the co-vertices of the ellipse are on the left and on the right of the center that are 4 units away from it, since B is equal to 4. Observe that these points are 6, 1 and negative 2, 1. With the vertices and co-vertices, we can now draw the ellipse this way. The foci are collinear with the vertices. Therefore, they are also above and below the center, which are 3 units away from it, since C is equal to 3. Thus, the foci are the points 2, 4 and 2, -2. The length of the latera recta is represented by 2b squared over a. Substituting the values of b squared and a, we will have 2 quantity 16 all over 5, which is equal to 32 over 5 units.
Finally, since the ellipse is vertically oriented, then the directrices are the horizontal lines with the equation y equals k plus minus a squared over c. Substituting the values of k, a squared, and c, we can see that the directrices are the lines y equals -7.33 and y equals 9.33 when simplified. I hope that you have understood the lesson. For the next video, we will discuss about finding equation of an ellipse. Thank you for listening and see you on our next discussion.